Hello makers. Okay, so in this video we're going to continue with the build of our Inmoov head. In the last video I mounted the servo driver, 16 channel servo driver, and off video I actually went through and identified each of the servo wires coming from these servos and labelled them, then connected them up. So that's all ready to go. We just need to connect that to this. There's also this camera feed which we also need to connect into this point here, but we'll do that later. The other thing we need to look at doing is mounting a power supply, which I have here, in around here somewhere. I was planning on putting a fan in here, but I can't really find a spot where I can put the fan that's not going to cause me some other issues like access to the SD card. So we're going to mount it here, and we're going to make up a connector to go onto here, and to make that connector I'm going to use two of these. These are 40-way headers. Now put them side by side, that gives me an 80-way header, but what I really need is a 20-way dual inline header. So what I'm going to do is I'm just going to pull this out to start with, work out where I need that. I need me side cutters. Okay, so with these you can put them all the way on, go to the pin just past these pins, and we can cut it. Unfortunately we do lose one. Yeah, we lose one pin, so it's going to be too short to use for the other half, which is a shame, but I've got plenty of these. They're actually relatively inexpensive. And we'll do it again. So we've got two 20-pin connectors. They're a single inline, but when you put them side by side you end up with two 20-pin, so a total of 40 pins. Now I could glue those together. I'm not going to bother at this stage. What I do need, however, is a map of what pins do what. Which I have here. So if I mount this on here, I can bring this up, and I know I need about that length. And that'll be long enough for what I need to connect onto this. Alright, so we're using green here is going to be our ground. We've got an output enable will then be the yellow, and I'll come back to the output enable. SCL, SDA, so serial clock, serial data for the I2S, and VCC. Now that's 3.3 volt. And the reason we're using 3.3 volt, not the 5 volt, which is available here, is because the SDA, or the SDA and SCL, are 3.3 volt signals. If we connected 5 volt to the VCC, then the SDA could potentially reach 5 volt, and that would destroy our Raspberry Pi, which we definitely don't want to do. So what we've got is a 3.3 volt here, our SDA, our SCL, and we've got our ground. Now the GPIO G clock, or GPIO 4, I'm not sure if I can access it yet from my robot lab, but what I'll probably do is tie the output enable. From memory it's a low signal, so I'll tie that to ground as well. Now when we'll solder those onto the headers here, so this is in the correct orientation for this. So what we want is all on this side, the first 1, 2, 3 pins, and then the 5th pin coming down, or pins 1, 3, 5 and 9. Now I have floating around here a small amount of heat shrink, and we're going to put that on the ends of each of our solder joints to stop the wires from potentially shorting together. Nothing worse than wires shorting together. So I've got the soldering iron turned on, it's heating up to 330 degrees C. It's already up to temperature, that soldering iron. Now I did have someone ask me at one stage what kind of soldering iron I use, and I can't pronounce it. It's spelt YIHUA 853D. It's actually a soldering rework station, and so I'll be using the hot air from it turned down to 200 degrees to actually melt the heat shrink, or shrink the heat shrink. Now if I was confident in being able to access that GPIO 4, I'd actually hook the enable up to it, but because I'm not, we're going to rely on turning the outputs on and off through software. Now I did put this under my magnifying glass because my eyes are getting pretty old. So we need the first wire, the second, the third, oops, and the 5th. Now I put a little bit too much solder on there and bridge 2 connections. That's where these things come in handy. This is a suction pump for sucking up solder. But I've got it tinned and that's what I wanted. Now, if you remember our layout, we've got our ground, output and enable tied together. Our serial clock is the orange, the serial data is the red, and VCC is the brown. Now, pin 1, so the one closest here, is our VCC. So we'll solder him up first. got him. Okay, so next to that was SDA. Well, that's convenient. SDA's the next pin we want. So red is our SDA and it goes on to the next pin. Now if you're wondering why I'm using the pliers to do this, it acts as a heat sink and stops it from the heat running up the wire and melting my heat shrink. Okay, so there we go. So this is before I've put the heat shrink over. There you can see they're all nicely heat shrunk on, and with that mounted in the head like so, that wire will come around, plug on to here and give me control and VCC power for our servo driver. So that's that part done. All jokes aside, that was the easy part. Okay, so there's my power input on this side and my mounting screw, and this is my output side. This part here screws into the rest of the skull and this part goes down to the face. So I want my output closest to the Raspberry Pi, so this way. So that started heating. This thing's remembering the temperatures that I set it last. My initial review of that 3D pen wasn't the best, but it's something you can get used to, I think. Now, for those of you who haven't watched my videos on PLA welding using the 3D pen, I like to run 200 degrees C. Not so much because that's a good temperature to melt the filament with, but it's a good temperature for the tip to be melting the base PLA that I'm connecting to. Now with this I'm only going to be able to tack weld it in 4 places. I might be able to get a seam right across. Seems to have worked. Soldering iron's already up to temperature. It's got a nice digital display on that soldering iron or soldering station. For those of you who remember the last video where I installed the power supply in under the jaw, I used the green wire for the ground and the white wire for the positive 5 volt. So that's our negative terminal there and our positive terminal here. Okay, so if we go back to our diagram here, on the other side, on the other header, so the end 2 terminals are 5 volt and then we've got a ground. So I'm going to connect to 2 and 3, so ground and 5 volt. That will connect up like so. I'll just do up this screw. Now I'm going to have to pull this out again in a minute, and I'm going to have to make sure I have it unplugged from the Raspberry Pi before I power it up for the first time, so I can set the voltage. Okay, so I need some more heat shrink. That terminal is 5 volt, as is that one, and this terminal here is our ground. In this case, our ground is the green wire, but it's going to be easier for me to do the white wire first, which is our 5 volt, or will be once I set the voltage on it. Now, the two terminals next to it, the ground, are actually serial. So if I wanted to hook up RS232 or TTL serial, they're the two terminals there. The next terminal after that, this one, is the big clock for our I2S. Right down here are the data in and data out for our I2S, and on the other side, the third pin is the left-right clock. And we'll probably steal the 5 volt from here to run the speaker, and I think from memory I need 3.3 volt from somewhere, which I can get on pin 17, so that's over on the other side. Alright, so let's do the heat shrink. Doesn't take long for this heat gun to heat up. It's actually a soldering station rework hot air, so it gets up to quite a substantial temperature pretty quickly, and it shuts down pretty quickly too. Alright, so I need at least one more colour wire for the power. Okay, this is a little bit heavier than I wanted to use, but I've actually run out of all the other wire I would normally use. But it doesn't hurt being heavier. It is just for the power supply from the battery supply to the power supply unit module. This is just bell wire, 0.75mm, cross-sectional area. The side with the black stripe I'm using for the negative. I've already set this one at some stage. It's bang on 5.10 volts. Typically when you get these delivered, they are tuned for 12 volts. So the next thing I need to do is get the hot glue out. Put some hot glue on each of those corners to keep this Raspberry Pi in place, and then we can put the skull back on the head, plug this into the board, the PCA 9685 board, connect the brown and the blue wire, which is for the servo power, along with these two wires for the Raspberry Pi power, and we can power it up for the first time. So I will have to sort out my hot glue gun first. Okay, so I've got my hot glue gun out and started warming up. So we're just going to put a dab on here. Now the beauty with hot glue is later on when I need to remove something to expand, the hot glue actually peels off quite easily. Now one of the things I plan to do in the not too distant future is play with a C Studio card for AI edge computing. I'm just going to put a little bit here to help hold this down because I suspect that that screw is not going to hold very well. So that should hold the Raspberry Pi in the head and prevent it from moving. This is a Servo Extension lead. I actually bought a heap of these a little while back. So I'm going to feed it down the neck of my robot. So I might grab another one and feed two of them down. And that way I can plug these into spare outputs on this servo driver. And that will allow me to operate the neck servos. When this does eventually get mounted on Fred, I've actually got switches, separate switches for turning things like the Raspberry Pis on and off and turning the servo power on and off. This is so that I can isolate any problems that might occur with the servos without shutting down the Raspberry Pi unnecessarily. I think this has got to be a bit heavier than I expected it to be. Okay, so this extra servo lead is for if I put another servo in for the side-to-side head tilt, which are these two lines here, and they're not connected to anything at the moment. So what I need now is a connector to allow me to connect all these together. Now I found these connectors. This is a 5-way Wago spring terminal, and I've also discovered recently that a few Chinese manufacturers are also making them now, which is handy. Means that they come down in price. But these have been used for a few years in industry, and I've found them to be very good. They are a lot more expensive than your standard single or double screw connectors, but they do allow wires to be connected and disconnected and reconnected quite a number of times without damage to the wires themselves, whereas screw connectors have a tendency to damage wires. They're good for single connections. The other thing is with screw connections, if they're a clamp type, they can come loose if you've soldered your joints like I have here. Whereas with the spring terminals, if you have them soldered, they don't come loose. The reason they are known to come loose with screw terminals is the solder will actually soften with use and heat, particularly if you've got a fair bit of current being drawn through. And that will cause a runaway situation where they will actually burn out. Whereas the spring terminals keep a constant pressure tension on them, so should the wire start to become loose, the spring just applies more tension, moves in, and stops it from becoming a problem. Okay, so when we look at this, you can see I've got a light on the Raspberry Pi, I've got a light on the servo board. Tip it up, you can see the light on the Raspberry Pi. A bit of glue string. So the power supply I'm using is putting out 6.1 volts at 0.448 amps at this stage. Okay, so this video is starting to get a bit long. Next week we're going to look at the programming side of it. So we'll fire up we've got the Raspberry Pi fired up, so we'll fire up the video capture and have a look and see what it's doing online. To make sure you get a notification for that, don't forget to click subscribe, click on the notification bell. If you've enjoyed this series so far, click on the like, and we'll see you next week.